Good morning, good afternoon, good evening, whatever time it is for you. How's it going? Today is April 29th, 8th grade mathematics. We're going to be working on assignment 8 today, but it's the same skill we've been doing this week, which is the solving systems of equations using the substitution method. And so yeah, we'll be doing some practice problems, letting everyone get logged in and situated. So timer's on the screen in just a moment. There it is. Get that out of the way. Come on. So let me make sure I've got the description on the screen for anyone just confused. We'll be doing numbers 1, 2, and 3 today. There we go. Morning. Babadoo. We are going to be getting into more practice problems here in a bit. Is there anything else I need to have on screen or announced? Is my mic working this morning? I've gotten so many emails about how I can't hear your video. Those of you, if this is your first video you're watching this week, my first upload of the week, my mic wasn't turned on, and I did not realize the first few minutes of the stream. So everyone else thought that their speakers were broken or computer was messed up. Nope, no. It was me. It was my problem. Anyway, chat, if you could confirm or disconfirm that my mic is working, it'd be great. Wonderful. Awesome. While we're waiting on anybody, do you have any questions about some of the problems that I've had you doing? Anything you need explained or reworked or whatever? You think you got most of them right? Well, I got the answers here. Which ones are you not so sure about? Morning, SpongeBob. I was just asking Tate which ones you had questions about from assignment number 7. Yeah, none of mine came out to be decimals. Yeah, mine all come out. I've got positive numbers, I have negative numbers, I got a 0, but none of them came out to be decimals. We'll give everyone another few minutes to join in. I'm sure they're all clamoring to wake up because it's time for math. Just checking my messages while people get logged in and situated. Three minutes until more practice problems. What day is Mother's Day this year? It's a rhetorical question because I'm immediately going to Google it, but I know it's in the next week or two. Mother's Day 2020 is Sunday, May 10th. So not this weekend, but next weekend. So everybody get on it. Mother's Day. Start working on whatever it is you're going to give your mother. SpongeBob, I just sent you a message. Hope that helps you get through problem number 5 on assignment 7. There's a siren. That means it's time to begin. So what we are doing today is we're going to be practicing this whole systems of equations thing using substitution method. And I'm going to start off with something I've done a few times now, but it's all right. Just a quick refresher on what in the world we are doing. We got to talk about what a system of equations even is. So you got your y-axis and you got your x-axis. And sometimes in this graph, you will have lines. So you might have this line and you might have this line. Who knows? It doesn't really matter which direction they're going. And sometimes those lines will crisscross once. Right there. So when we're talking about a system of equations and we're talking about solving them, I guess it's important you just understand what in the world we're talking about. So the solution is the x and y value where these two lines crisscross each other. Now, not every system has, and by the way, when I say system, I'm just meaning the multiple lines in the same graph. Not every system has two lines that will crisscross. Sometimes you'll have parallel lines that never cross, so there's no solution. And sometimes you'll have two lines that are the exact same line and cross in all xy values, but most of the time they only cross once. And what your job and my job is today is to figure out what that location is. Let me go back to drawing for a second. So there's going to be an x value and there's going to be a y value that go to this spot, and we're going to figure out what that is. The only problem is we don't have a graph. We don't have a picture of a graph. We just have the equations of the lines. So let me show you how that's going to work with something called substitution method. Okay. So first, make sure no one's confused. This will be our first practice problem of the day. Here we go. So here's our system of equations. It might not look exactly like the ones on your assignment, but it is super duper similar. Let me get up my math practice standards real quick. There they are. Okay. Checking chat. Good morning, Michael. Okay. So this is our first practice problem of the day. Let's see what we got. Okay, if you would notice real quick, within these two equations, I've got y equals -2. So what we're going to do is we're going to take this other equation, and right here where the y is, we're going to jam in the -2 because we've been told that y is equal to -2. So I'm going to write down 4x minus 3. But instead of using the y, I'm going to substitute what y is equal to. So that's -2 is all equal to 18. So 4x minus 3y, in this case, we're using -2 in its place, equals 18. Okay. So let's go ahead and do this multiplication. So we end up with 4x. -3 times a -2 would be +6. So 4x plus 6 equals 18. Okay, so far, what have we done? We've made sense of the problem and we're persevering to solve it. We're being very precise with our mathematics. Let's see, right about now though, it's time to do some abstract thinking because I'm going to subtract 6 from both sides to get rid of that on the side with the variable. And that is using our abstract laws of mathematics, because now 6 and -6 make it 0. So I've still got 4x. (18 minus 6 is 12. But these all made zeros. So what do we do last? Okay, so another inverse operation using our abstract rules. If I were to divide both sides by 4, because that's the opposite of multiplying by 4, 4 divided by 4 is equal to 1. So that's 1x. And 12 divided by 4 is equal to 3. So in this case, this is a really quick one. More in Austin. This was a really quick one because it already told us what y was equal to. So our solution to this one, x is equal to 3 and y is equal to -2. And if we wrote that as a coordinate pair, it would just be 3, -2. So that's the location where these two equations cross when they're drawn up as lines. That one was really simple because I didn't have to go back and replace and do anything extra. Thanks to them just telling me that y equals -2. Let's do another one. Now that it's Wednesday, there's always the possibility that I'm going to do one I've done in a previous stream, but that's fine. This one's a little more complicated than the last one, which is all good. So here's my system. Now, I don't believe any of the ones I put on your assignment actually require this extra step, but they all require the same skill. So here's what's going to happen. Right now, I want to use the substitution method. I want to just take a value for y or a value for x and jam it into the other sentence. But in this case, neither equation is ready for that. So we've got one little extra step to do. So let me show you what we're going to do. We're going to take this guy and we're going to do some manipulation just with him for a minute. So let me write him again up here. So that's -4x plus y equals 6. Now, if you're asking yourself, Mr. Matthews, why this one and why not the other one? My experience with these is so vast. I've done so many of these. I'm really accessing a lot of repeated reasoning. As soon as I saw these two sentences, I realized very quickly with one inverse operation, I could turn this one into a y equals stuff. And if I wanted to do the same with the other sentence, it would require multiple steps. And I'm just lazy. I want to do things the fastest way possible. So here's what we're going to do. If I want this just to end up being y equals stuff, I've got to get rid of this -4x. So I'm going to add, if I had another color, hang on. I'm going to add 4x to both sides. And I know the 6 doesn't have an x on it, don't worry. The reason for this is that once these cancel each other out, what I'm left with is y equals 4x plus 6. Now, I can just use that in place of this. So this is because of the same thing. Y equals 4x plus 6. Now, the reason that was so important is now I actually have a y equals stuff, and I can take this 4x plus 6 and put it anywhere I want for a y value. And that's what we're going to do right here. So I'm going to take this sentence now, and instead of using y, I'm going to plug in this thing that we just discovered by doing our manipulation. So I'm going to have -5x minus, now I would say y, but I know that y is equal to all this stuff. So I'm going to say minus 4x plus 6 is equal to 21. So there's my substitution method right there. That's my substitution method. I figured out that y is equal to this stuff. So I go to the other sentence and I write it down, but instead of using the y, I use that stuff in its place. And the reason that was so vital is that now there are only x's. So instead of me having two variables, I've only got one variable, which is a good thing. Okay, so my next step, when you see a negative symbol next to parentheses like this, that's really a -1. So we're going to take that -1 and we're going to multiply it by both terms on the inside of that binomial. That means there's two things on the inside of the parentheses. So I'm still going to have -5x, but -1 times 4x is -4x. And -1 times a +6, yeah, that's a -6. And that's all equal to 21. So now I've got negative 5x and negative 4x. Those are like terms because they both have x's on them. And I can combine those. So minus 5x being combined with negative 5x being combined with a negative 4x would be negative 9x. I'm going to do some inverse math here. I'm going to add 6 to both sides. Just so I can get rid of this from the left side of the equation. So I've got negative 9x equals 21 plus 6 is 27. That's where we're at right now, which is great because now I can divide both sides by a negative 9 and get that x, that's 1x because negative 9 divided by negative 9 is a positive 1. So that's 1x. That's our abstract reasoning. What else have we done so far in this problem? Let's see, we've persevered in solving it. We're being very precise for our mathematics. Okay, back to it. Let's see. So that's 1x is going to be equal to 27 divided by negative 9. That's going to be negative 3. Positive divided by a negative is going to be a negative answer. All right, so x, yikes. So x is equal to negative 3. So we're halfway there as far as our answer goes. Because all of these answers, we're looking for the crisscross point. We're looking for that xy value. So now we know that half our answer, I don't know why I drew next there. Half our answer is negative 3. Well, now we have to figure out what y is equal to. So let's look back up right here. Get a different color so it stands out. We had a sentence earlier on that said y equals 4x plus 6. And that's how we're going to figure out what y is. So we're going to take this value, which is x equals negative 3, and we're going to plug it in for the x value right here. So that means that y equals 4 times negative 3, because that's where the x was, plus 6. Well, that means that y is equal to negative 12 plus 6 because 4 times negative 3 is negative 12, which means that y is equal to negative 12 plus 6 is negative 6. And there it is. The solution to our system, the place they crisscross, is at negative 3, negative 6. X is negative 3 and y is negative 6. Okay. Until someone pumps the brakes and says, hey, stop, explain this. Where'd that come from? Where'd that come from? I'm going to move on to another problem. And I'm hoping by now everyone's got their own piece of paper out and they're trying these along with me, maybe even trying to solve them before I get to a solution. That would be pretty sweet.
Hey, Mr. Matthews.
What's going on, Jagon?
Ain't we working on 4, 5, and 6 tomorrow? Or
yes.
today?
I'm posting 1, 2, and 3 for assignment 8 today. I'm posting 4, 5, and 6 for assignment 8 tomorrow.
What problem are we on? 3 or 2?
I haven't shown any of those problems yet. These are all practice problems.
Oh.
Yeah, I meant to. I labeled the first one. I didn't label that one. Sorry about that. So I'll do that now.
Oh, I was just asking.
Why is it people say that? Oh, I was just asking. I know that. You asked me a question. So therefore, I know you were just asking. People seem to think they have to apologize for asking questions. You don't. Ask away. Let's try this one. Okay, so Chad, here's the first question. What which of these two equations is going to be easier? Here's my system. Which of these two equations is going to be the easier one to turn into y equals stuff or x equals stuff? That's the first bit of intuition that'll really get us started on the right foot. The top or bottom, which one is going to be the easier one to turn into y equals stuff or x equals stuff? Top or bottom? Giving chat a second to respond while I drink my water. I've got one answer that is correct from chat. Anybody else want to chime in? Yep, I agree. The one that's going to be really easy to turn into y equals stuff is the top one. So real quick, let's take this guy and manipulate him just for a second. So that'd be negative 5x plus y equals a negative 2. And the reason this one is so easy to turn into y equals stuff is just with one swift motion, if we just subtract 5x from both sides using our abstract law, that'll make it 0. Wait. Correct that. Don't worry that the 2 doesn't have an x on it. That's all right. They're not going to mix, but I just need to get rid of this 5x, this negative 5x. Ooh, wait a minute. The opposite, duh. The opposite of subtracting 5x is adding 5x. Whew, that was close. Okay, so then, because these are opposites, they're going to make it 0, which is what I was planning. That's why I did that. So I'll just end up with y equals 5x minus 2. Y is going to be equal to 5x minus 2, which is great because now I actually have a value for y that I can plug in right here in the other equation. One second. Okay, let's see now. Let me get a different color. Okay, so now what we're going to do is we're going to rewrite this sentence here, but instead of using the letter y, because we know that y is equal to this stuff, we're going to put in this stuff in its place. That's the substitution method. So we have negative 3x plus 6. Now it would be 6y, but instead I'm going to put a parentheses and put in this stuff, 5x minus 2. And that is all equal to negative 12. Okay, so now that we've done the substitution, what is next? Well, right here, I need to do this positive 6. It needs to be distributed into this binomial. Whenever you see a number up against the parentheses, you need to multiply by everything on the inside. So we'll end up with negative 3x. So 6 times, positive 6 times a positive 5x, that'll be plus 30x. Positive 6 times a negative 2, that'd be minus 12. That's all still equal to negative 12. Well, now I notice that I've got negative 3x and 30x on the same side of the equation, so I can combine like terms. So negative 3x plus 30x, that's going to be 27x. And I'm going to go ahead and do some inverse operations. I'm going to add 12 to both sides. Because that'll get this negative 12 to go away. Negative 12 plus 12 makes a 0. So 27x is equal to negative 12 plus 12. Whoop. I guess we're equal to 0. Anytime, just so you guys are aware, anytime I get a 0, my brain says, is that true? And I quickly backtrack. Well, negative 3x, 6 times 5x is 30x, 6 times negative 2 is negative 12. The opposite of that Is adding 12? Yep, definitely 0. So for those of you that hit the panic button, it's all right. What we're going to end up doing, we'll divide both sides by 27. And we're going to get that 1x is equal to 0. Because 0 divided by 27 is still 0, because 27 goes into 0 times. 27 divided by 27 is equal to 1, so that's 1x equals 0. Okay. Fine by me. That'll probably make the rest of this really easy. So I know that part of my answer is that the x value is 0. So now we're going to take that and we're going to jam it up here. Remember we had that y equals stuff? Let me get a different color so it's easier to see. Right here we had y equals 5x minus 2. Well, now we're going to use this value for x in that sentence. So that's y equals 5x. So I'll put 5 parentheses 0 end parentheses. So there's my 5x minus 2. So y is going to be equal to negative 2 because 5 times 0 is 0. I'm pretty sure in both assignment 7 and assignment 8, you'll have one question each that has a 0 as one of its answers. So don't panic too much. It does happen. Okay. I think we'll do one more, and then I'll post the questions 1, 2, and 3, unless you guys are just desperate to get it over with and get started. I'll let chat decide. One more practice problem, or should I just post up 1, 2, and 3 for assignment 8? If no one votes, I'm going to do one more practice problem because my vote counts double. Okay, no one's anything, so we're going to do one more practice problem. And so no one's confused. This is a practice problem. Now, what will be amazing is everyone watching right now would pause it and try to solve this and then catch up to me on the replay and see if you got the same answer I did. I'm going to tell you now that one of these equations is really, really easy to turn into an x equals stuff. See if you can find it. So here's our, wait, hang on. So here's our system. This top one is the one that's really easy to manipulate because we can turn this into x equals stuff pretty easy. Because right now it's x plus 3y equals 1. Well, if I very quickly just take away 3y from both sides, and don't worry that that doesn't have a y. I don't need them to mix. I just need to get rid of this one. What we end up with is x equals negative 3y plus 1. Thanks to our abstract rule where 3y and negative 3y cancel each other out. And if you haven't noticed, I'm going a little bit faster at making sense and persevering to solve them. My abstract reasoning is automatic because I'm using repeated reasoning while being precise. Once you've done a bunch of these on your own paper, they get really much easier. You can't just watch me and nod along saying, yep, I'm getting it. If you don't have your own paper out and you're practicing these skills and getting some muscle memory, it's not going to get easier. You got to do them yourself too. So now what we're going to do is take this equation. So we're going to take this x. So x is equal to negative 3y plus 1. And we're going to plug that in for this x value. This is the first practice problem today where we're substituting for the x value instead of the y value. which is fine. So now let's take this guy, and instead of writing x, we'll put this stuff because we know that's what x is equal to. So that'd be negative 3x, but instead of x, I'm going to put a parentheses and put negative 3y plus 1. So there's my substitution method. And I still have to put in this minus 3y equals negative 15. At any point I've gotten past your question, pause it and keep working, and then unpause it and see if we end up with the same work. So the next thing I'm going to want to do is I'm going to take this negative 3, and it needs to be distributed into this binomial, so I need to multiply it by both terms. So negative 3 times negative 3y is going to be positive 9y because of my integer rules. Negative 3 times positive 1 is negative 3. So negative times negative is positive. Negative times positive is negative. Now I've still got this minus 3y is equal to negative 15. So now I immediately spot that I've got a 9y and a negative 3y, and they can be combined because they both have a y. They both have like terms. So 9y minus 3y is 6y. 9y minus 3y is 6y. And let's go ahead and get rid of this negative 3. Let's go ahead and add 3 to both sides. So what ends up happening, these cancel out, they make it 0, which is what I was hoping for. 6y will be equal to negative 15 plus 3, that'd be negative 12. So if we just go ahead and divide both sides by 6, we'll end up with that y is equal to negative 2. Because these 6's divide by each other make 1, so 1y is the same as y. And negative 12 divided by 6 is negative 2. So now what we're going to do is we're going to take that and go all the way back up here. Remember we had this sentence. We had x equals negative 3y plus 1. Well, we're going to jam that y into that sentence and figure out what x is equal to. So this would become x equals negative 3. And now that'd be times y, but we know that y is equal to negative 2. Plus 1. And just to keep track of our answer, I know that we need an x and a y value. And right now we know that y is equal to negative 2. That point they crisscross. Now all we need is the x value. So okay, well, negative 3 times negative 2, so that'd be, so x is equal to negative 3 times negative 2 would be 6 plus 1. Negative 3, yeah, negative times negative is positive, so that means that x is equal to 7. So there it is. So x equals 7 and y equals negative 2. Well, I hope these practice problems have been of some use to you. So now I'm going to go ahead and post assignment 8 questions 1, 2, and 3. Clear all the drawings. Get my mouse. Bye, 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 bye. Okay, here we go. You know what? Just so no one's getting confused. There we go. Okay, dokie.
Mr. Matthews,
Yeah.
you put 8th grade math periods one. Oh, one. Oh, I thought you. Never mind. I thought it
Okay.
was talking like question 1, 2, and 4. That's what I thought it was.
No, it's all right, man. I'll make these easier to see in just a second. There they are. So 8th grade math, periods 1, 2, and 4, assignment 8. Yep. Questions 1, 2, and 3 are all posted. Just as a little friendly tip, you'll notice that x is equal to all this stuff. So you're going to jam that value in right there for x to do your substitution method. You notice on question number 2 that x is equal to all this stuff. So you're going to jam that in for this x and do the substitution method. And on question 3, you'll notice that x is equal to this stuff. And you're going to jam it in right there and do your substitution method. So if you're watching this on the replay, I hope you're all doing well. And I hope that this has been an insightful session. So feel free to pause now and rewind and go back and watch me work the other problems to see how they work. And if you have to do them on your own paper, I strongly encourage you. I would say it's absolutely vital that you work out these problems on your own paper and then look and see if your scrap work looks like my scrap work. Otherwise, like if you're watching and going, yeah, that makes sense. Yeah, that makes sense. No, you're not learning anything. You're just kind of agreeing with what a math teacher is saying. That's different than trying it for yourself. So stay healthy, take care of your families, make your beds every day. Every good day starts off with a made bed. And I'll see y'all next time.